In this video, we are going to go over how to find the slope of a line that goes through two given points. But you're typically going to be given this problem as literally just numerical points and be asked to find the slope of the line without graphing. I'm going to show you how this connects with your understanding of slope being rise over run and a formula that we're going to be using in a short little while, so that whenever you're given 2 points, you can just go right to that formula and use it, but have the comfort in knowing where that formula comes from, so that you're not just memorizing something random. Let's do this! So we are asked to find the slope between the points 0, 6 and 1, 4. So basically we're being told that you have a line that has a slope that, well, will go through those 2 points. So the line goes through these points, so maybe we'll graph it first. But in later problems, you're not going to have to graph a thing. So if we were to graph this, you would have 0, 6, so it'd be up 6, way up there, right? Up 1, 2, 3, 4, 5, 6, and then the point 1, 4. Let's graph that now. That's over 1, up 1, 2, 3, 4. Perfect. You only need 2 points for a line, right? So there's going to be a line that goes through this, like so, right? And that line just kind of continues on. But what I'm concerned with is the slope between these 2 points. Well, if you use rise over run, you can see that you are going down 1, 2. So I'm going to make those marks here, make a little triangle down 1, 2, so that's -2 when we run over 1. So that would be a rise over run of -2 over 1. Again, the rise going down 2 for every 1 we go over. So you can certainly plot out these points every time and get a nice slope. But there's a formula that goes with this, and I'm going to show you how that formula connects with rise over run. So the way that I'd like you to eventually be able to do a problem like this is without having to graph. Now, the formula goes like this. I'm going to write it out first and then explain what it means. It is the change in y, we've heard that before, which is y2 minus y1 over x2 minus x1. You might be looking at that being like, dude, Mr. Groden, what the heck is that? First of all, these numbers right here are called subscripts. Sub means below and script means writing, so it's writing below the variables. The reason why they're different numbers is we're saying that we have 2 very different y values over 2 different x values. It's not the same point each time. Where are these points? Well, it doesn't really matter which of these is point 1 and point 2. But this would be point 1, x2, y2, and this would be point 1, x1, y1. So I'm going to let this be x1 and y1. It's your x coordinate and your y coordinate. And let's let this be x2 and y2. That's all we've got. So now this formula allows us to plug everything into it, and that will give us our rise over our run, which I'll explain at the tail end. So let's plug in these points. We've got y2, which is 4, minus, and we'll flip around this way, y1, which is 6, all divided by. Now we'll do x2, which is 1. Notice it corresponds with the y value of 4, minus x1, which is 0. And once we simplify that out, we'll get 4 minus 6 is -2, over 1 minus 0 is 1, ooh, which is a rise down of -2 and a run of 1. The formula works. A couple important parts in using this formula correctly. When you choose your x1 and y1, your x2 and y2, you must stick consistently with the order that you plug in your second and first points. Since we picked 4 to be y2, 1 must also be x2. That's because when we graph this line, we want it to be a nice continuous flow and see that this thing is going down and right, not down and left, right? So by keeping the points together, we're showing that. We're starting here our values at 1, 4, and we're saying, okay, if I start at 1, 4 and do 4 minus 6, that's getting me to go up, and then 1 minus 0 is getting us to go left, which gives the exact movement of that line just going backwards. So that's important. Keep everything in order. The second thing that is important with all this is really take your time when simplifying. You don't want to mess around with your integer math and go too fast. That's where we see really silly errors. Now, why does this formula work with rise over run? Why is it the same thing as just graphing it out? And why do I think it's better? When you get quick at this, you won't have to graph anything out. You'll have your answers. So why does it work? Well, let's take a look at the graph. We have a point here at 0, 6. How much do we change from 6 down to a y value of 4? 2. How do we get that change? 6 to 4. You're subtracting. y2 minus y1. Isn't that awesome? And then, how do we get from this point, x equals 0, to x equals 1? You're subtracting again. x2 minus x1. Just to show you that it doesn't matter which order we do things in, you'll still get the same value. We could have switched up the y2 values, the 2 values, and the 1 values. So let's say that instead we did 6 minus 4 over, and now we go back to the 0 because it corresponds to the 6, 0 minus 1. That's going to give you 6 minus 4 is 2 over negative 1, and you still get negative 2, or down 2, right 1. Very cool stuff. I'd stay consistent. I usually name the first point I see point 1 and the second point I see point 2. So, moral of the story is y2 minus y1 over x2 minus x1 is the change of the y values over the change of the x values, and that is rise over run. On the other side of this video, I'm going to go over a much more abbreviated example so that you're feeling better with this stuff, and I'm going to do it first by using the formula and then by seeing that it's the same on the graph. Stay tuned for that. On this side of the video, we're going to do one more example with finding slope when given 2 points using the equation m equals y2 minus y1 over x2 minus x1. Oh, and by the way, m, as weird as that letter is, stands for the slope. I know that's a strange letter to be using, but m actually stands for the slope of a line. I never quite understood why we picked that variable to represent slope, because mope doesn't make much sense, but let's mope about slope. No, that's not very positive. Okay, so anyway, let's jump into this. So remember, we're going to assign x values and y values as 0.1 and 0.2, so I'll call this x1. This therefore is y1, and this point is going to be the second point, x2 and y2. And now it's as simple as following our equation right here. So y2 is 3 minus y1, which is 1. That represents the change in y. x2 is 2 minus x1, which is, be careful here, negative 3. And I say be careful because you want to include that negative sign. Now slow down, do your integer math, don't make any simple mistakes. 3 minus 1 is a positive 2, all divided by 2 minus a negative 3 becomes plus 3. 2 plus 3 is 5. So we have a slope of 2/5. In other words, if I were to plot those points out, we would see that to get from one point to another, we would rise 2 and run 5 to get there. Let's confirm that. So negative 3, 1 is a point here, and the other point, 2, 3, is a point here. Do we indeed rise 2 and run 5 to get from one point to the other? Well, we go over 1, 2, 3, 4, 5, and up 1, 2. Nice. So think of the slope almost as the movement of a line, and sure enough, whoop, you would get a line with rise of 2 and run of 5. I've got some extra bonus content on the other side of this video. For those of you that are just like, I want even more in-depth understanding, I will show you how the rate of change actually is the same as slope and rise over run. So I'm going to do that. Actually, I'm not even going to go to the other side of the video. I'm going to do that right now. But if you're like, no, you know what, Mr. G, I'm cool with finding slope. I get how to do it on a graph. I get how to do it with the slope function. That's this guy. Then you're in great shape, and I will see you in the next video. But for those of you who are curious as to how rate of change is slope or rise over run, here we go. So to look at that, I'm very simply going to take these points and write them in a table format, because that's how we were looking at rate of change. So I've got my x values and my y values. I've got negative 3 is my input and 1 was my output. I've got 2 is my input with 3 being my output. And if you take a look at the rate of change, remember we look at the differences between the x's and the y's. So the difference from negative 3 to 2, or the amount that we change, is up 5. And the change from 1 to 3 is up 2. And then if you remember, the rate of change is comparing how y changes as x changes. Well, that would be up 2 over 5. Oh, and that's slope, that's rise over run, and it is this formula right here as well, because how do we get the plus 2? We do the y value minus that y value. 3 minus 1 gives us plus 2. Nice. To get the plus 5, we do this x value minus that x value. 2 minus negative 3. x2 minus x1. It's a short explanation, but it's a powerful one because now I hope that you see that rate of change, slope by understanding it as rise over run, and y2 minus y1 over x2 minus x1 are all the same exact idea, just different ways to represent slope, rate of change, rise over run, change in y over change in x.